Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on January 15, 2026, about 6 days ago. It presents the first comprehensive survey of autonomous issue resolution, showing that state-of-the-art agents have reached resolved rates exceeding 60 to 70% on various benchmarks, a massive leap from earlier models that struggled to solve any tasks at all. The paper is titled, Advances in Frontiers of LLM-Based Issue Resolution in Software Engineering, a Comprehensive Survey. And as we'll see later, the rapid progress in this domain suggests we are getting much closer to fully autonomous software engineers. And for those interested in the implementation, the authors have shared their code on GitHub. Figure 1 illustrates the end-to-end workflow for issue resolution. On the left, the process starts with the inputs, a natural language problem statement, and the existing codebase. In the top right, an AI agent, using methods like SWE-agent or open hands, analyzes this context to generate a code patch. This patch is then applied to the repository and run against unit tests, leading to the final evaluation steps at the bottom, which determine the resolved rate. Figure 2 provides a structured taxonomy of the entire field, categorizing recent papers into 3 pillars: data, methods, and analysis. The top section focuses on data, separating established evaluation benchmarks from the emerging pipelines for automated data synthesis. The middle and largest section details methods, which split into 2 main camps: training-free frameworks that orchestrate agents, and training-based techniques that fine-tune models using supervised learning or reinforcement learning. Finally, the analysis block at the bottom groups studies that examine data quality and failure modes. So, while Figure 2 outlined the broad landscape, Figure 3 now drills down into the specific components of these systems. On the far left, the data section highlights the shift toward automated pipelines, which splits data construction into collection and synthesis. Moving to the center, the training-free methods panel breaks down how agents operate without wait updates, employing frameworks like single-agent or multi-agent setups alongside tools for fault localization. Finally, the right column covers training-based methods, where models are explicitly refined using supervised fine-tuning or reinforcement learning algorithms like PPO and DPO. Well, Figure 4 zooms in on the specific tool modules that empower these agents. The diagram organizes these tools around the central repair workflow. Across the top, we see the sequential stages of execution, starting with bug reproduction, which creates a script to trigger the error, followed by code search, patch generation, and validation. To the left, the agent uses internal frameworks and memory to guide its decisions. Finally, the bottom row displays support tools like fault localization, which helps pinpoint the exact location of the bug within the files. Alright, moving from the tools to the data, Table 1 inventories the datasets that fuel these agents. The list is split into 2 primary categories: single programming language datasets on the top, which mostly focus on Python, and multi-programming language datasets below that expand to Java, Rust, and C++. One key column to notice is environment, where the checkmarks indicate which benchmarks provide a runnable setup for executing code and verifying fixes. The scale also varies wildly, shown in the amount column, ranging from small, high-quality sets like SWE-bench verified to massive training corpora like SWE-fixer with over 100,000 instances. So, while Table 1 covered datasets, Table 5 presents the general foundation models evaluated on issue resolution. Unlike specialized agents that are fine-tuned for coding, these general models rely on what the table calls an inference scaffold. This column lists frameworks like agentless or open hands, which structure the model's interaction with the codebase. The strategy works surprisingly well, as top performers like Mimo v2 Flash and CatCoder achieve resolved rates of roughly 73%. Wrapping up, 2 key takeaways stand out. The field has rapidly graduated from simple code completion to complex, repository-level issue resolution. However, high compute costs and data contamination risks suggest that while AI software engineers are becoming a reality, robust deployment still faces significant hurdles. That's it for this episode of the AI Research Roundup. I'm Alex, thanks for listening.